In the previous session, we saw the indefinite integral of cos nx times sin mx dx. Now let's look at the definite integral of sin mx times cos nx dx from 0 to pi by 2. Applying the definite part of this formula, minus 1 by n plus m times cos to the power of n plus 1 x times sine to the power of m minus 1 x from 0 to pi by 2 plus m minus 1 by n plus m times the integral of cos nx times sine m minus 2 x dx. Now, the first term disappears. Why? Because we have a product of cos and sine, and it is from 0 to pi by 2. So cos pi by 2 is 0 and sine 0 is 0. So this term disappears. We are left with m minus 1 by n plus m times the integral from 0 to pi by 2 of cos nx times sine m minus 2 x dx. This can be written as I sub m minus 2 comma n. When we apply the formula again, we get m minus 1 by m plus n times m minus 2 minus 1 by m minus 2 plus n times I sub m minus 2 minus 2 comma n, which is basically I sub m minus 4 comma n. We are repeating it again and again so that we end up with m minus 1 by m plus n times m minus 3 by m plus n minus 2 times m minus 5 by m plus n minus 4 and so on till we reach 2 by 3 plus n times I sub 1 comma n. Now we will reach this and we will have I sub 1 comma n when m is odd. When m is even, same thing. The only thing is last term would be 1, or last factor will be 1 by 2 plus n times I sub 0 comma n. So now we have to figure out I sub 1 comma n and I sub 0 comma n. So let's do that. I sub 1 comma n is equal to integral from 0 to pi by 2 of sine x times cos nx dx, which is equal to minus cos to the power of n plus 1 x by n plus 1 from 0 to pi by 2. Now, if you want to verify, you can differentiate this and see whether we get back sin x cos nx. And when we evaluate this definite integral, we get 1 by n plus 1. Now, what about I sub 0 comma n? We have sine disappearing. Cos to the power of 0 x is 1. So that disappears. We are left with integral of cos nx dx from 0 to pi by 2. And this we know, we have already derived this. So we get n minus 1 by n times n minus 3 by n minus 2 times n minus 5 by n minus 4 and so on up to k. And what is k? K is pi by 2 if n is even and k is 1 if n is odd. I sub m comma n when m is odd becomes m minus 1 by m plus n times m minus 3 by m plus n minus 2 times m minus 5 by m plus n minus 4 and so on times 1 by n plus 1. And similarly, when m is even and n is odd, we get this. Here you will notice that the last factor is 1. When both are even, we end up with this expression. The last factor being 1 by 2 times pi by 2. Okay, now let's look at an example for this with some concrete values for m and n. We are looking at I sub m comma n is equal to integral from 0 to pi by 2 of sine 6x times cos 8x dx. So here the powers are both even. That means we are going to use this formula. It becomes so mechanical once we know this. 6 minus 1 by 6 plus 8 times 6 minus 3 by 6 plus 8 minus 2 times 6 minus 5 by 6 plus 8 minus 4 and so on. And then 8 minus 1 by 8, 8 minus 3 by 8 minus 2, 8 minus 5 by 8 minus 4 times 1 by 2 times pi by 2. If we evaluate this, we get 5 pi by 4096. So that was an example of a definite integral with concrete values for m and n. Now, till now, we have been looking at mostly sine and cos. Yes. But we are not restricted to that only. We could use some other functions as well. So let's see. Say we have I sub n is equal to integral of x to the power of n times e to the power of ax dx. So here again we are going back to the indefinite integral. Now here we do a substitution. U is equal to x to the power of n, which implies du is equal to nx to the power of n minus 1 dx. Now, if we have taken u as x to the power of n, that means dv is equal to e to the power of ax dx. And to get v, we integrate both sides. We get v is equal to e to the power of ax by a. And now integrating by parts, we get integral of x to the power of n times e to the power of ax dx is equal to x to the power of n times e to the power of ax by a minus integral of e to the power of ax by a times nx to the power of n minus 1 dx. So we have done the uv substitutions. So here if you notice, x is getting reduced. So I sub n, let's say this is I sub n, is equal to 1 by a times x to the power of n times e to the power of ax minus n is a constant, a is a constant. So we take it out of the integral, we get minus n by a times the integral of e to the power of ax times x to the power of n minus 1 dx. This is the formula for this integral. Now, let's look at a very, very interesting result based on this. Now, here a is equal to minus 1. So, what will happen? E to the power of minus x it will become. Here also e to the power of minus x it will become. So, now the definite integral that we are going to look at is I sub n is equal to the integral from 0 to infinity of x to the power of n times e to the power of minus x dx. And if we apply the definite integral version of this formula, we get minus x to the power of n times e to the power of minus x from 0 to infinity plus n times integral of e to the power of minus x times x to the power of n minus 1 dx. Now here what all has happened? Remember a is minus 1. So this has become minus x. This is minus x. This is minus x. That is one thing. Second thing is here, remember we have minus n by a. But a is minus 1. So minus minus plus it becomes. And we are left with only n. And finally, one minus will come up here because we have 1 by a and a is minus 1. I sub n is equal to, I'm just rewriting it in a different way, minus x to the power of n by e to the power of x from 0 to infinity plus n times the integral of e to the power of minus x times x to the power of n minus 1 dx. Now this becomes a 0. Now here you have to be careful. You have to realize that the numerator is a polynomial and the denominator is an exponential. So that means when we do substitution with infinity, the denominator will grow very, very fast or much faster than the polynomial. So that means this will become 0 or it will tend to 0. And when we substitute 0, 0 to the power of anything is 0. But in the denominator, we end up with e to the power of 0, which is 1. So that will also be 0. So this first term disappears entirely and we are left with only the second term. So we have in is equal to n times the integral e to the power of minus x times x to the power of n minus 1 dx, which can be written as I sub n is equal to n times I sub n minus 1. Now what's the fun as it goes forward? I sub n minus 1 is equal to n minus 1 times I sub n minus 2. I sub n minus 2 is equal to n minus 2 times I sub n minus 3. And we keep going in the same pattern. We have I sub 1 is equal to I sub 0. And I sub 0 is I sub 0. That means we have to still figure out what I sub 0 is. So combining all of them into I sub n, we get I sub n is equal to n times n minus 1 times n minus 2 times n minus 3 dot 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 2 times 1 times I sub 0. So which means I sub n is equal to n factorial times I sub 0. We have to figure out I sub 0. So I sub 0 is equal to integral from 0 to infinity of e to the power of minus x times x to the power of 0 dx. X to the power of 0 is 1. So disappears. We have I sub 0 is equal to integral from 0 to infinity of e to the power of minus x dx. We integrate it. We get minus e to the power of minus x from 0 to infinity. And taking care of the limits, we get minus e to the power of minus infinity minus e to the power of minus 0. That minus minus will become plus. E to the power of minus 0 is 1. Now, this can be written as minus 1 by e to the power of infinity, which will tend to 0. So 0. So we have 0 plus 1, which is equal to 1. So I sub 0 is 1. Substituting I sub 0, we end up with integral from 0 to infinity of x to the power of n times e to the power of minus x dx is equal to n factorial. So that was interesting, right? Now, if you found this useful, don't forget to like, share, and subscribe. Questions, suggestions, and opinions are always welcome. Thanks for watching. See you in the next session. That's it for now.